What is the distance formula?
It is square root of x.
Square root of
X2 minus x1.
x2 minus x1 squared
Plus y2
y2 minus y1
with the
squared. Okay, and there's our square root. So we have two coordinates. We have our x1, y1, and x2, y2. So we plug in, right? So what is my first one I'm plugging in?
It would be
9 minus negative 8 squared plus negative 6 minus 3 squared. My square root. Okay. What's 9 minus a negative 8?
A equals 17. It's a plus. It makes it a plus.
It makes a plus, so 9 plus 8 is
17.
squared. What is negative 6 minus 3? Negative 9 squared. What's 17 squared? 289. What's negative 9 squared? A negative times a negative is a positive, so we have positive 81. What's 289? 370. What's the square root of 370?
19.23.
19.2.
Does it matter what we go to whatever? Like after the bill?
No, one decimal place is fine. One decimal place is fine. Okay, so get out your packet.
The one from today or yesterday?
The one from yesterday. Not the one from today. We're going to go over the one from yesterday. And we're actually just going to go over half of it. By the way, Abby, I have yours. Okay, so how we're going to do this is I'm going to go over number 1. And then you do number 2. Then I'll go over number 3. You do number 4. Then I'll go over number 5. Yes, it was from yesterday. Okay. A lot of people had some questions on these, how to do them. So I'm going to go over. So, number 1, it says graph the given set of points, then answer the questions that follow. So I have 5, negative 2. So everybody graph, if you haven't already. 5, negative 2, negative 3, negative 2, 0, negative 2. Oh, sorry, that's wrong. Very good. And then I have negative 2, negative 2. So I have 4 points on that I've written. And it wants us to identify the domain. Now remember, when we're looking at the domain, are we looking at X or Y? We're looking at X. So I'm going to have this nice little T-chart. I'm going to have 5, negative 2, negative 3, negative 2, 0, negative 2, and negative 2, negative 2. So if I'm looking for the domain, what are the points that are there on my X side?
5, negative 3, 0, and negative 2.
5, negative 3, 0, and negative 2. What about my range?
Negative 2.
Negative 2, negative 2, negative 2, negative 2. So I'm just going to write it once. Negative 2. Then it asks, is the relation a function? And explain. You say yes. Why yes?
Because it doesn't repeat. The points don't repeat.
The x's do not repeat. Okay? X's do not repeat. So yes, it is a function. And because x values do not
Also, the x value repeats.
repeat. Yep. Okay. And if you remember our vertical line test,
Yeah, I did the vertical line.
and that's perfectly fine. If you say yes because it passes a vertical line test. So we have these points right here.
Well, this one passes the vertical line.
Yeah, it does. So it is
the other one over here. But it's not.
It doesn't. Okay. So a vertical line test, we draw a line, and if it only hits at one point, it's a function. Okay. Okay. So the next line connecting these points.
There's no sharp angles.
No sharp angles.
So it's not,
Continuous, the definition for continuous
it's
means that there is infinitely many points on the graph. Okay, so let me show you what that means. I'm going to have two examples over here. This is my first one. And my second one looks like this. Okay. How many points do I have on this first graph? I have 5 points. There are 5 points there. How many points do I have on this second graph? There are infinitely many points on that second graph. Because if I wanted to know what my y value was for when x is equal to 1, it would be 1. But what if I said, what is my y value for x is equal to 0.3427815882? That'd be somewhere over here. Okay. What if I said for 0.3427815883? See how many x values I can make? I can go out to the, 100 decimal place, 100 decimals down, or 100 places down.
Can't do it. Like actually can't do it.
Not going to. Because that will take a long time and you're just trying to waste time. But there are infinitely points on this line. There's every few, there's just infinitely many. That is what I mean by continuous. Over here, we said there's 5. That is discrete. When you can count how many points there are, and you can say there's 5 points. That is discrete. When they're connected by a line, that line tells you that you can go out so many decimal
so
places.
that's continuous.
This one's continuous, right here. Continuous.
Okay, but like, how it tells you to graph them, right?
Mm-hmm.
So every time they tell you to graph them, it's only going to be a line.
No, it's not.
Okay, so it's only going to be discrete.
So whenever it just gives you points, it's going to be discrete. And this problem, number 1, only gave us points. And there were these points right here.
So
Okay?
It's discrete.
discrete
So it's discrete. Now, look at this number 2. Real quick, continuous or discrete?
discrete.
Discrete because it gives you points. Okay? It doesn't give you an equation. If it gives you an equation, that means they're going to be connected. Or if it gives you a graph that already has lines going through it. Okay? As you'll see in the next page. So it's discrete. It's going to be discrete because it gives you points. Now let's turn the page. Number 2 you're going to do on your own if you haven't already. Okay, so number 2 you're going to do on your own if you haven't already. So let's look at number 3. It says identify the domain. Domain is what axis? X or Y?
X.
X. What is my furthest point over here on the left? What's that at?
4.
-4. And what's my furthest to the right?
4. 3.
+4. Now, so my domain is going to be in between those two numbers. Now, we're going to write it in a special way, and I want you to recognize this is a closed point, and this one is an open point. Okay? So, my domain is going from -4, and so x is going to be, or -4 is less than or equal to x, and we add that equal to because it's a closed point. It's a solid dot. But x is just less than +4. We do not add the equal sign underneath because it is a open circle right there, an open dot. Meaning x can be -4, it can be -3, it can be -2, it can be -2.582. And it can be x is equal to 3.99999, but it cannot be x is equal to 4. It cannot equal 4 because of that right there. That open circle, that open dot, that open point. Okay? So it can get infinitely close to that point, but it will never reach positive 4. And that's why we don't include the less than and equal to, the positive 4 sign. So let's look at our range. What is the lowest value that we have on that graph?
We look at the ones.
Yeah, now we're looking at the range, the y's.
Uh,
And what's my highest?
Alright.
5. So I'm going to go from negative 4, I'm going to have 5 over here. And I'm going to have a y in the middle. Fill in the symbols.
Less than or equal, and then no, it's less than.
Just less than. Again, it's just less than because it will never reach negative 4. It'll get to negative 3.999, but never gets negative 4 because of that open sign. And then on the other side,
Less than or equal to.
less than or equal to, because I have a closed point up at the top. Up the top. Does that make sense?
Yeah.
not really.
What? Got it? Okay. Next bullet says, is it continuous or discrete?
It's
That's
discrete.
three.
Is there infinitely many points, or can you count the
Yeah.
number of points? There's infinitely many because the lines are drawn. That means at this point right in here, that's x is equal to, what, negative 2.857213842. Okay, so it is continuous. It is going to be continuous because there are infinitely many points. Infinitely many points.
How do you know?
Infinitely many points. Is the relation a function? Does it pass the vertical line test? Yes, it does.
So that's when the x's don't repeat, right?
Yeah, when the x's do not repeat. So yes, because it passes the vertical line test. And lastly, it says if it is a function, tell the intervals where it is increasing and decreasing. So let's look at this. From negative 4 to negative 1, this part right here, what is it doing? It's decreasing. So we're going to have an increasing section and a decreasing. Increasing and decreasing. So between negative 4 and negative 1, it is decreasing. So I'm going to put that down here. Negative 4 less than or equal to x less than or equal to negative 1. Now let's look at this section right here. That's from negative 1 to 1. What's it doing there? It's increasing. So from negative 1 less than or equal to x less than or equal to 1. It's increasing.
Is it always going to be less than or equal to?
No. Remember up here on range? Because look what we're coming up to next. Now let's look at this one right here. What's it doing?
Decreasing.
It's decreasing, so I'm going to put it down here. And it's going from 1 to positive 4. 1 to 4. Now look at my signs. From 1 is less than or equal to x. But what about on the other side? It's just less than because we have that open symbol again.
I wanted to think if that's what it's put in. Wow.
Okay. Now on the other side, you're going to do that side on your own.
We don't have to do that last part.
Yeah, you don't have to do it if it's not a function. Okay. Last page that we're going to go over. We're going to go over number 5. So it says, for the given equation, develop a table of values, produce a graph, then answer the do is I'm going to grab my graphing calculator. So everybody grab your graphing calculator. And you hit your y equals button. And you type in 8 parentheses 0.5 or 1/2 in parentheses. Then you hit the little caret button. The caret button, which looks like that caret button. It's right underneath the clear.
Why do they call it here?
I don't know. It's not caret. And then you're going to hit the X. You're going to hit graph. What does that graph look like?
It looks like this. Pretty.
Looks like that,
Yeah.
right? Put our arrows.
Hey, it's the
Yes, it is. What is it?
it's an exponential.
It's an exponential. So we've already gotten this over here. Our parent function is exponential. Because that's y is equal to b to the x. And in this specific equation, your b is going to be between 0 and 1.
There's supposed to be one and B.
No, I accidentally. I was going to write it next.
Wait, what is it?
0 is less than b is less than 1. Remember those exponentials? We had two different ones. That's one of them. The other one was b is greater than 1. And in b is greater than 1, the graph looks like this. Remember that? But this would be is less than 1, so it looks like this one right here. Okay. Now it wants you to fill in this chart. So what you're going to do is you're going to hit the second button, the yellow button, and then you're going to hit graph. And you get that table. And you're going to fill in the numbers. So -1 should be 16, 8, 4, 2, 1,
half. 2.5.
and
1.25.
okay. So it keeps getting smaller and smaller. So there we filled in our graph. Now it says identify the domain and the range. Now let's look at the domain. Domain is x values. So here's my x-axis. Now this line, it's going up and it continues going this direction forever. So will it get to all these negative numbers over here?
Yes.
Yes, it will. What about this way? This continues on forever. Will it get to all the positive numbers? Yes, so my domain will be all real
Can't you
numbers.
just get that little weird bar thing?
Yes, for this. All real numbers. Now my range, is there any negative numbers on my y-axis? Is my y-axis? My graph never gets down here. So there's going to be no negative numbers. Where does it stop? At 0. Does it hit 0? It doesn't. So I'm going to have one of those with no equal sign on the bottom. So my y is going to be greater than 0. And that would be my range. Now it says identify the intervals where the function is increasing or decreasing. Is it increasing anywhere?
Yes. No.
No.
It's going up to X.
It's going down this whole time, so it's always decreasing. Decreasing everywhere. Is it continuous or discrete? Continuous or discrete? Continuous. And we already identified the parent function. Okay, the rest of the packet